All right, so we're going to pick up where we left off. We're looking at question C, and we're using our graphing calculator to estimate the population after 7 days and then after 2 weeks. But here's the thing, that 2 weeks needs to be converted to days because everything that we do is per day. So we're going to look, instead of 2 weeks, we're going to look for 14 days. So we're going to look at 7, which we already have, and it is 226.82. So 7 days is equal to 226.82, which obviously, if we are estimating, is going to be about 227. And then, of course, 2 weeks, we're going to look for 14 days. So we're going to go down to the 14. Thought we were going to go down to the 14. If you look at 14, it should be 514.49. So 14 days is 514.49. Sorry, guys, my calculator is lagging. Which, of course, rounded is going to be about 514 rabbits. All right, and it says using your graphing calculator to find the doubling time. Okay, so we're going to look for where our answer is equal to 200. So really what we're doing is we're looking for where do we get an answer of 200 rabbits when our equation is 100 times e to the power of 0.117t. Again, we're going to take our calculator, and if we look at it, we can see we get an answer of 201.78 at 6. So we're going to say that at about 6 days, we will have 200 rabbits. All right, so now we're looking at question 2 for our test review. We're going to determine whether the given function is exponential or not. How do I know if it's exponential or not? Well, is it going up by multiplication or is it going up by addition? All right, so I'm looking and I'm figuring out, how do I get from 2/3 to 1 and then from 1 to 3/2? Well, if I know my math, I know I'm going to have to multiply by 3/2 to get 1, and then 1 times that same 3/2, and then to get to the next one, I'm going to multiply it again by 3/2, which, if I know my fractions, is actually 1.5. And remember, when it's greater than 1, when my ratio or my rate is greater than 1, then I know that it is exponential growth. And of course, I'm going to follow the directions, and it says to use h of x equals c as our starting value. Well, the starting value is always going to be your y-intercept, and our y-intercept is just 1. Our a, well, that's our growth rate, so I would either put 3/2 or I would put my 1.5. And of course, raised to the power of x. But again, to make my final answer, I actually do not need the 1. It's an understood 1, really. So this would just be 3/2 to the power of x. All right, question 3. Sorry, guys, give me just a second. Okay, so question 3, we're going to need our calculator. And we're going to need the y equals in our calculator because we're going to plug it in. Okay, so we're going to graph 3 raised to the power. The x minus 2 is all one exponent, so I'm going to do x minus 2 and close my parentheses because it's all in my exponent. And I'm going to take a look at my graph. Ooh, I need to recenter my graph. So what I'm going to do is I'm going to hit zoom 6, which is zoom standard, and it's going to take me back to my standard screen. And what I'm going to do is I'm going to take and I'm going to look at the table. So second table, I have an idea of what it looks like, obviously. And I'm going to go up because I want some of the negative and I want some of the positive. So I'm going to do x and I'm going to do my y. And I'm going to use, I like -2, -1, 0, 1, 2, and maybe 3 for good measure. So negative 2 is 0.01, negative 1, 0.04, 0.11, 0.33, and then 1, 3. All right, so I'm going to plot those points. So negative 2, 0.01. So it's practically on the line, but not quite on the line. Negative 1 is 0.04, so just a little bit more. 0 is 0.11. Again, all of these are really close to the line, but not quite on. 1 is 0.3, 2 is 1, 3 is 3. And to make sure, I'm going to just go down. I'm going to look for one more. 4 is 9. All right, so now I can take, and I know that I get really close to the x-axis, but I don't actually cross it. So I'm going to make sure I draw my full line. Make sure you have your arrows at the end. And because it gets really close to the x-axis but does not cross it, I know that I'm going to label him as my horizontal asymptote at y equals 0. I do not have a vertical asymptote. He just keeps going on and on to infinity. So now I just have to work on, well, I also have my y-intercept, by the way. My y-intercept is at 0 and 0.11. And of course, now all I have to do is write my domain. So on my x values from left to right, it keeps going on and on forever. So this is negative infinity to positive infinity. My range is different. It is affected by that horizontal asymptote. So from the bottom to the top, so going from the bottom, I'm going up, I'm affected by that 0. So my 0 is my starting value, and it goes on and up to positive infinity.